All right, everyone, welcome to another Python video. We will be solving the basic statistics problem. And it says the following: create a function for each statistical analyst tool, mean and median. Each function should take a single list of integer as an argument, and then we're going to output the result. If you don't know what a mean is, it's the calculation of the total average from a given list of integers. So our argument for this function is going to be a list of integers, and we're going to calculate the average. I just have pass here as a little like a placeholder for the code that we're going to write. And we have the median function. It's going to find the middlemost value in a given sorted list of integers. So we're going to need to figure out how to do that. And we're going to return that middlemost value. Now, before I start, I wrote this testing area here. I have imported two very important functions from the random module. Seed helps us always generate the same number of random numbers if we set a value to it. So if I set 1, every time I run this code, this list here is going to have random numbers that are the same from the previous execution of this Python file. So we're controlling our randomness, but just to make sure that we are getting the proper outputs and we can properly test our program. This right here, you're seeing something called a list comprehension that you should have read about in your textbook. Okay, so what it's doing is creating a list, and each item in our list is going to be a value from the random range function. Starting from 1 all the way up to 100, but not inclusively. So it can be any numbers from our random range. Okay, and we're going to have this many value. If we're going to repeat this line of code this many times, range many times in terms of, well, we're going to pick a random number from 10 to 30 so that we're picking random numbers with the random size of our data set. So if we were to run this code, you would actually get this: 73, 98, 9, 33, 16, 64, 98, 58, 61, 84, 49, 27, 13, and 63. And if I were to run it again, I would get those exact same random number. That is because I have set this function called seed to be 1. Okay, so if I were to change this value to 2, and I'll get this totally different random data set. But if I were to run it again, I get the same one because our seed value is not changing. The values that we often generate random from is from a random seed. But if we have a fixed seed, all the numbers generated afterwards will be the same numbers over and over again. All right, so for our sake, we'll just go back to 1 and remember that this is our data set. Perfect. Let's calculate mean. This is a very simple function where we can just write the entirety on a single line. We're going to say return. We're going to take and use the sum function, which adds up every single numeric value that we can have in an iterable object, and list is an iterable object. So we're going to say sum up all the values in a list, and then we're going to divide that by the length of our list. And that's how you calculate average, right? You take a total sum of all individual items in a series, and then you divide it by the size of that series or sequence to get the average or mean. So we can say that's end of mean. Okay, so we can say the print f mean of our data set is equal to, we can run the function mean and give it data. Let's see how that code works. Right, and because 53.28 blah 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 blah, that is the average of all these numbers put together. We have an average of 53. Alrighty, let's do median, the middlemost value in a given sorted list of integers here. So that one's gonna be a little bit more coding, so we're gonna say end of median here. All right, first and foremost, we need a sorted version of our list, so we can say sorted a list is equal to, well, the result of sorted on our a list. Now you can also do a list dot sort. Now the difference is this will mutate our a list, whereas sorted creates a new list. So one thing problematic with this is the following: is that our a list right here, this a list is connected to our given argument when we call it, which was going to be end up data in the future of this code. Well, then that means that data is going to be mutated whenever we run this code inside our function, which is something that you don't want to do. That is a function with side effects affecting mutable data types, and that is not a good thing to do. Therefore, I'm using the function called sorted so that I can just create a like a sorted list of some sort. Okay, and we're gonna do two things. We're gonna we're gonna find the middle point, which is going to be length of our list, and we're gonna floor divide by 2. And then we're going to say, well, if length of our A list modulus 2 is equal to 0, we have even number of data points. Otherwise, here we have odd number of data points. Right? So in a situation like this is very simple. We can say return from our sorted A list. We can just go to the index of middle and return that value. Whereas here, we're going to have some different value. We're going to have a let value. This, let me just double check. If we were to have 1, 2, 3, 4, 5, 6, 6 items, 6 divided by 2 is 3, so we'll be here. So this will be the rightmost value, and we have to go left value is going to be sorted A list at middle minus 1. And then we get to return the following. We're going to return left plus right divided by 2. And let's do that, divided by 2. Okay, cool. So let's check the median of our data set. All right. Print just to see, we can say our sorted data set is equal to sorted data. Okay, so if we were to sort and we're in some sort of a middle here, we'll be right here. We have 6 to the left, 6, sorry, perfect. We have 58 plus 61 divided by 2 gives us 59.5, and that is our median value. And it's working nicely where we were able to handle a data set with even number of items. So let's see what happens if we were to try it with the seed of 2. Right, we were able to grab the middlemost value, which was 40 in a sorted data set. We have 5 to the left here and 5 to the left here, and we were able to get that middlemost value with our if statement, right? Where if the length of our list was even, we had to do this calculation of looking at the two most middle number and take an average, whereas if we had an odd number of items in our list, we just go to the middle point and just grab that value. All right, so that was our mean and median function. I hope you enjoyed this video. And as always, thank you for watching and stay classy.